So for 11.4, we are going to talk about nonlinear inequalities. So linear inequalities, x is greater than or equal to 4. We know how to do those. But as soon as you throw more than one variable into the mix, it gets a little weird. So we're going to just do some of the homework problems together to get you started, and then you'll have the rest of the class to continue. So what I would like to do is I would like to start with one like number 1. The quantity of x minus 4 times the quantity of x plus 3 is less than 0. Okay, so let's start with that one, and then let's talk about what we know about that. This language right here, this tells us that we are looking for negatives. So we're asking ourselves, where is the multiplication of x minus 4 and x plus 3 negative? Okay. Now, we're going to talk about it a few different ways, but first let me kind of show you algebraically how to do it. So we want to do it algebraically and not have to focus on what the graph looks like, but I'll show you how the graph kind of lines up with it. Okay, so this is what you're going to do. If it is in factored form like this one, which is great, it has to be related to 0, which it is, which is great. What you're going to do is you're going to set each individual factor equal to 0, so we can find where the individual zeros are for those factors. So we get x is 4 and x is negative 3. Okay. Now we're going to put those on a number line. Now you need some room above the number line. So you notice we have some of this kind of empty space right here. I've done that on purpose. We need some space above it. So let yourself have a little bit of room above it. And we are going to put the values that we just found the zeros for on number line order. Okay, so you're going to go from negative 3 into 4. Okay, now the next thing you're going to do is you're going to look at the actual inequality. If it does not include a negative, or I'm sorry, the equal to, if it's just negative like this one is, I want you to put open circles there, meaning I'm not allowed to equal 0 where I found, so I'm going to put open circle to designate that. Okay. Now we're going to turn this number line into a chart. So we're going to kind of extend those little bars up. And on the left side or the right side, it doesn't matter which, I'm going to put the factors we found, x minus 4 and x plus 3. Now what we're going to do is we are going to do what I call test values. We're going to test some values along the number line to see if when we plug them in, do we get positive values or do we get negative values? So I need something on the number line that is less than negative 3. And it can be any number less than negative 3. I'm just going to go negative 4. That's going to be my test value in that region. I need a test value between negative 3 and 4. If 0 is in that region, I think that's a great test value because plugging in 0 is usually really nice. And then I need a test value that's after 4, so why not 5? Now those can be any numbers within those regions. Any numbers will work. I just usually pick nice integer values that can plug in very easily. Now we're going to plug them in, and the only thing we have to ask ourselves is when we plug them in, do we get a negative value or do we get a positive value? Okay, so if I plug negative 4, so I'm going to test this region over here. If I plug negative 4 into this, negative 4 minus 4 is negative 8. That's a negative. Then I'm going to plug negative 4 into that. Negative 4 plus 3 is negative 1. Now those two are multiplied together. Last I checked, a negative times a negative gives us a positive. So that region there is a positive region. Now let's do the same thing for the middle region here. Let's plug in 0. If I plug in 0 to the top, I get negative 4. If I plug in 0 to the bottom, I get positive 3. Last I checked, a negative times a positive is a negative. And then we're going to do it one final time. We're going to plug in 5. If we plug in 5 to the top, 5 minus 4 is a positive. 5 plus 3 is also a positive. Positive times a positive is a positive. Now we have to think to ourselves, what were we looking for? Well, this right here, less than 0, numbers that are less than 0 are negatives. So we need the negative portion. So we're going to color in the negative portion. And that's our answer. Now, an answer like that is not on the number line. It's not helpful. So we are going to write our answer in two different ways. We're going to say that x is between -3 and 4. So that's one way. That would be more like a set notation or an inequality notation. But we are preparing for calculus, so we need to be able to put things into interval notation. So I want the interval that x is between -3 and 4. Now we're going to put parentheses there because of the fact that those indicate that we did not have an equal to. Okay. Now, how could the graph, what do we know about that? Well, x minus 4 times x plus 3 is the quantity of x squared minus x minus 12, which is a parabola. The parabola looks like this. So if we ask ourselves, where is that parabola less than 0 or negative, that parabola is negative right there. So that's how the parabola would go with what we found algebraically. So if they are factored, like number 2 and number 3 and number 4, 5, those ones, or number 1, 2, 3, and 4, those are in factored form. So since those are in factored form, you're going to proceed like that every single time. Okay, so let's do one more. Let's do number 4 before we move on to one that is not in factored form. Now, don't worry about the fact that this one has 3 different things. You're going to do the exact same thing. Where is x plus 8 equal to 0? Well, that's at -8. Where is x plus 2 equals 0? Well, that's at -2. And where is x minus 3 equal to 0? Well, that's at 3. We're going to need a number line, and you're going to put those values on the number line in number line order. So -8, -2, and 3. They do happen to be in good order. Now this time, when we look at our symbol there, greater than or equal to 0 means we can equal 0, so 0 and positives. So we want 0 and positives for that particular one. So at the zeros we found, -8, -2, 3, and 3 this time, we're going to put closed-in dots. So the last one, we put open circles because we were not allowed to equal 0. This one has the equal to symbol, so we put in closed dots. Now, just like we did before, we're going to turn this into a like a chart. So extend those up, extend those up, extend those up. Now, we have 3 quantities here, 1, 2, 3. So we need 3 sections. So I'm going to go 1, 2, 3. And I'm going to write them in any order along the side here. Now, just like before, I'm going to need some test values that follow the number line. Okay. So my first test value needs to be to the left of -8. So why not -9? Now, it can be any value within that region, but why not? Okay. This one, I need something between -8 and -2. Why not -3? Here, I need something between -2 and 3. So I'm going to go 0 because I always choose that if I can. And then this region, I need something to the right of 3. So why not 4? So those are going to be our test values so we can determine whether these things are positive or negative. Now let's plug -9 into all 3 of those things. If we plug -9 into the top, we get negative. If we plug, because we get a -1. -9 minus 2 is also a negative. -9 minus 3 is also a negative. Now, 3 negatives multiplied together is still negative. So we're going to put a negative symbol down there. Now we're going to continue this process. We have to do it 3 more times. If I plug -3 into all of those, I get a positive. I get a negative. I get a negative. This time I only have 2 negatives. 2 negatives are going to make a positive. So that region is positive. Now we have to test 0 into all of those. We get a positive and a positive and a negative. We only have 1 negative, so it's a negative. And then if we plug 4 into all of those, we get a positive and a positive and a positive. 3 positive is a positive. Now, it won't always go negative, positive, negative, it won't always flip-flop back and forth. Many times it will because of the nature of the numbers that are going to be plugged in. If there are bounces in the graph, those are the ones that don't always follow that rule. If we were to look at this graph, it looks something like this. Wait. I missed one there. It looks something like that, and we know how to graph those things. Now remember, we are looking for where this graph is equal to 0. That's why we put the dots. And where it's greater than 0, the positives. So this time, please, could you fill in the positives? Now there's a positive here. And then a positive here keeps going. So make sure you include that arrow. So for inequalities, we would say that x is between and equal to -8 and -2, or x is greater than or equal to 3. Now that's the inequality version of your answer. I don't want the inequality version. I want the interval notation. Okay, so we would say that x can equal -8 up to -2. We put it in brackets this time, and it's all because of this equal to symbol back there. And then you use your union symbol, that's for the word or. And then we can go from 3 to infinity. Now what's great about this answer is it follows the number line perfectly. We are between -8 and -2. We are from 3 to infinity. Okay, so I want both answers, but the preferable one for what we're trying to accomplish is that bottom one. Does anybody have any questions about number 4? Okay, now for the first time I would like to do one that is not in factored form. Before we do that, just so I don't forget, can you make this an 8? The Notability thought my 8 was not an S instead. So for number 9, that should be an x plus 8. Okay, so now I would like to do number 8 with you. So if you could please look at number 8. There's a few things that are different looking about number 8 than we had seen before. Can anybody tell me one thing we see that's different? Anybody notice anything about number 8 that's a little different? It's not factored, so that's one thing for sure. Anybody notice anything else? There's an X over there, there's not a 0. So there's 2 things we have to fix. The order in which we want to always fix them is first we want to get it related to 0, then you're going to get it in factor form. So the first thing I would do to fix this problem, to get it more like the ones we had just seen before, is to subtract 6x from both sides. Now remember, addition or subtraction does not change the symbol that we see in an inequality. It only is going to change if we multiply or divide by a negative number, which we haven't done. We're just subtracting. So we get x squared plus 10x plus 24 is greater than 0. Now, only once it's greater than 0 or equated to 0 somehow do we want to get it into factor form. So if we can think of what are the factors of 24 that add up to 10, that would be 6 and 4 add up to 10, but multiply to give us the 24. So this is going to be x plus 4, and x plus 6 is greater than 0. So now we are ready to do what we did for the other problems. Okay, you're going to set x plus 4 equal to 0, x plus 6 equal to 0. You're going to put them on the number line. You're going to make the number line chart, but you can only do that once you get it in that form. Okay, now let's before I move on from number 8, you will have to finish that one, but any questions about number 8? Okay, let's talk about number 10 for just a moment. Okay, Now we're going to jump to number 10. The factors that are there, you may recall that if there is an even power on something, on the graph there's a bounce at that location. That bounce makes it flip back around. So that bounce is going to affect whether it's positive or negative. So when you make your plus or minus chart for this one, okay, I'm going to get you the chart started. This gives us a 0 at -8, at -5, and at -7. When you make that chart and you put them in number line order, you do that like normal. Because of the equal to right there, we're going to close those dots in. But when we go to make our chart, when you write them down on the side here, you must include any powers. Okay, when you write them down on the side of your chart, you have to include any powers, and then you have to square it. Because when I square a negative, it's going to become a positive. So you have to include, for number 10, you must include the powers in order to make the chart. If you do not include the powers when you make the chart, you did not do it correctly. Okay? Okay, so that is basically 11.4. So you have the rest of class. I want you to be working on this stuff. Please note that the grading period is coming. It's almost done. So if you are missing anything, please get those things into me as soon as possible. Okay? Any questions at this point? Okay, you work on this stuff. And if you need me, just ask.